PCIe. The Peripheral Component Interconnect Express, universally known as PCIe, is the absolute backbone of modern computer expansion. Introduced in the early 2000s to replace the aging legacy standards, it completely revolutionized how internal components talk to the processor and the motherboard chipset. For any hardware technician, mastering the PCI Express architecture is mandatory, as it connects everything from high-end graphics cards to lightning-fast solid-state drives. The shift to serial communication and lanes. The biggest technical leap from the older standard was the shift from a shared parallel bus to a dedicated serial point-to-point connection. Instead of all devices taking turns on one massive shared highway, PCI Express gives every single device its own private, dedicated road directly to the central processing unit. These dedicated roads are called lanes, and they are the key to understanding the incredible speed of this interface. Data travels across these lanes in pairs, with one set of wires dedicated to sending data and another dedicated to receiving data simultaneously. A technician will identify the speed and physical size of a connection by the number of lanes it utilizes, which is denoted by an X followed by a number, such as X1, X4, X8, or X16. Physical architecture and cross-compatibility. The physical slots on the motherboard directly correspond to the number of lanes they support. An X1 slot is very short and is typically used for low-bandwidth devices like dedicated sound cards or internal Wi-Fi adapters. An X16 slot is much longer and is almost exclusively reserved for power-hungry graphics cards that need to push massive amounts of high-resolution visual data to your monitor. One of the most brilliant engineering features of the PCI Express standard is its physical cross-compatibility. A technician can take a tiny X1 network card and plug it safely into a massive X16 slot. The motherboard is smart enough to detect the smaller card and will simply route the data through the first available lane while ignoring the rest. This incredible flexibility allows builders to utilize whatever slots are physically available on their motherboard without worrying about matching the exact sizes. Generations and backward compatibility. Since its inception, the PCI Express standard has evolved through multiple generations, from Generation 1 all the way up to Generation 5 and beyond. With every new generation, the engineers managed to double the data transfer speed of the previous version. A Generation 4 X16 slot is twice as fast as a Generation 3 X16 slot. However, they also maintained perfect backward and forward compatibility. If a technician installs a brand new Generation 4 graphics card into an older Generation 3 motherboard, the card will still work perfectly. It will simply slow itself down to match the maximum speed of the older motherboard slot. This ensures that users can upgrade individual components over time without having to throw away their entire computer system. Power delivery through the slot. Beyond just transferring data, the PCI Express slot also delivers electrical power directly to the installed expansion card. A standard X16 slot can provide up to 75 watts of continuous power. While this is plenty for network cards and basic capture cards, modern high-end gaming graphics cards often draw 300 watts or more. This is why technicians must connect additional dedicated PCIe power cables directly from the power supply to the top of the graphics card to make up the difference.